Power User Group. We have Jonathan here, co-founder, CEO, and John Champion. He is going to talk about the refactoring, stuff that we're here for. So, give him a hand. I have all this other stuff. You can look at that on
yeah, that's enough. Yeah.
Chairs.
I'm always in the front, so that's where I'm at.
One thing we often say, the software industrial revolution has arrived. We've got a lot of automation in our software development process, heavily componentized, very automated, steady, increasing that direction for a long time. I saw this industrialization about 10 years ago at Netflix. I was working on engineering tools. They were, of course, famously one of the original proponents of microservice development. So they had kind of gone hard on that, like component, just let's ship new like individual microservices very quickly, use off-the-shelf stuff, go. And then on the backside of that, after a few years, we had 20, 30,000 microservices, and there became the problem of like, how do we keep those reasonably up to date with some degree of like I learned about a new pattern, how do I apply that across the existing code base? And so one of the interesting cultural dynamics there at Netflix was this freedom and responsibility culture, which meant that no central team could impose constraints on what product engineers did. So faced with the problem like, hey, I've got 20 or 30,000 microservices that are on Java 6 and we're trying to get them to 7, I couldn't just say, hey, like on a particular date, if you're not there, we're just going to start breaking your build. Right? That would be anti-cultural, against the freedom and responsibility principle. So probably like most well-meaning people, we on engineering tools started with trying to provide context about where you were today, providing dashboards, providing feedback, providing workshops to help you learn how to do it yourself, and all this kind of thing, to try to kind of just gently nudge people in the right direction. And it resulted in approximately zero action towards the objective that we were trying to achieve. And so as I would go around asking people, what could I do really to give you the like information you need to move forward, like what can I do to make you move forward, they would say, do it for me, otherwise I got something else to do, right? I've got the next feature to ship, whatever the thing of the day is. And that was always a bit sarcastic, let's be honest, but there's a truth to it. There was a lot of feature pressure on them as well. So obviously there were only 2 of us on engineering tools. There was about 700 engineers at that time. I can't do all their work for them, so we started thinking about what exactly does it mean to do it for them. Because of that same freedom and responsibility culture, this problem was particularly ugly there, in that there was no stylistic consistency across the organization. Tab spaces, build tooling, dependencies in use, they're just all over the place. So very unlike highly centralized, single Java format, monorepo organization. This is like the exact opposite of that. From inside that culture is where I founded Open Rewrite, which we'll go into a little bit today. This is designed for large-scale automated refactoring and achieving these kinds of things in a way that's style preserving to whatever the repository looks like today. And it really could have only been, I think, born out of that extreme kind of environment. I went from Netflix to Spring Team. That's where I met Olga. We were working on an unrelated product called Spinnaker for continuous delivery, working with a lot of large enterprises, and we saw a lot of organizations struggling with this. Like, I have a lot of code under maintenance. I'm trying to move it forward, or I'm trying to consolidate tech stacks towards some North Star architecture, and it's just a lot of things to deal with, so just not able to do it. interestingly, the JP Morgan that we were working with at the time, Fidelity, Home Depot, etc., more closely resembled Netflix than it resembled Google. Maybe not intentionally. Netflix was intentionally freedom and responsibility, do whatever you want. JP Morgan was like, I'm trying to be consistent, but there's 60,000 of us, and we're just not going to be consistent. We're on 20 time zones, and there's 60,000 of us. So good luck if in that organization you want to enforce a particular consistent pattern, whatever that pattern might be. So I think one of the things that that was apparent from the beginning at Netflix with the 20 or 30,000 microservices, and is apparent today at most of the places we work that have tens, hundreds, thousands, tens of thousands of repositories, is that the means that we have of production, which is like the IDE and the tools that support that, are insufficient for upkeep, essentially, because as a developer on one product team, I might have 100 repositories in my organization, or 1,000, whatever. I can't have all of those open in the IDE at the same time. And so for any given operation that I want to achieve kind of horizontally across that surface area, I don't want to have to go about it by like opening one of those repositories at a time, making the change, committing, opening the next one, the next one, the next one, the next one. Curiously, even GitHub today, if you really think about it, is very much a single repository experience. Like issues, single repository, PR, single repository, commits, single repository. I don't really know of a feature there, and this is true of all the version control systems, that really grasps the fact that we're dealing with like a multi-repository problem in many cases. So that was kind of the setup here of why this is a problem. I'd like to show maybe from the end what multi-repository refactor looks like, and then work back to the data and the process that operates, that makes that possible. And then once we understand that, we'll show why that data is important to AI use cases in a little bit. So it's a bit of a meandering thing here, but I think of like what I'm going to show here for a moment is just a view of a particular organization. And so say like I'm looking at this Netflix and Spring organization, and we're dealing with about 200 repositories of open source code. And say I set the priority, say this is my code, and I'm set the priority, I want to move all of these code bases to Java 21. What effectively I want to be able to provide to that product team is first like visibility into where I'm at relative to the goal, and then ultimately to basically have that upgrade button. This is what that Netflix engineer was saying, do it for me, where I can click into any given repository and I can see that something has made the change, prepared it for me. So there's a new pattern, and the question is going to be, why did this change, right? There's a new string formatted pattern in Java 17 that's not a static method, it's an instance method. That's kind of nice to know. There's a new sequence collection mechanism in Java 17. That's nice to know. Maybe I should, or Java 21 rather, maybe I should adopt sequence collections as a new idiom that was just unavailable to me before. And so the recipe, the thing that's making this change, is OpenRewrite's making all of these changes in a way that looks idiomatically consistent in the context of this repository. So if you use tabs, I'll use tabs. If you use spaces, I'll use space. I'm going to make it look like a developer here did all of this. But when I do this on an organization, like in this particular case, there were 6,500 files that needed to be changed in order to accomplish all the both necessary requirements and moving to the latest idioms to get to Java 21. And so I want that change to have been done by something that's predictable, right? Because if I have to review every single one of these, it's going to get very boring, and I'm going to start missing the places where it's like almost right, but not quite right. So that's the kind of experience that I want. And ultimately, I want a developer to be able to say, commit directly or create a pull request, and for this commit, like this commit button to be an operation on 136 repositories at once, not on one repository. That's the kind of end state goal that I was going to achieve. And so then, as the engineering tools person at the center of the organization, I still don't control that commit action, right? Like I'm not doing it for them in the sense that I'm clicking the commit button, but I'm able to say kind of like, I want you to get here, and I've done it for you. All I'm asking you to do is review it at a moment of your convenience and commit it. And can we agree that that's like a pretty good balance of work? And it's kind of unacceptable if you don't do it at some point. So that's the sort of experience that we've been trying to develop. So some of the data that supplies this kind of operation, to make this kind of confident, correct change requires a certain amount of data and a process. And the data that we're operating here, we call a lossless semantic tree, which if you reach back in history to your compilers class, you can probably remember abstract syntax tree. It's like the source code is text, and the parser is going to tokenize that, create a structural representation of it. The bit that's not often talked about is what the compiler does next with that AST, which is it's going over all of those symbols that it finds in that tree, and it's trying to figure out, when I see like a variable, what's the type of that variable? When I see a method, what declares that method? And importantly, some of that information that the compiler is trying to use to figure out what this thing is not actually visible in the text. So this is actually a fully formed kind of hypothetical class here. There's nothing omitted. It's a dog that, like Charlie, that extends animal, and animal must be the thing that's defining some sort of protected field, logger, and I'm inheriting that logger field. So nowhere in the source file of dog do I see type definition of logger. I don't see an import statement for that. I'm just logger dot, and I'm starting to use methods on it without any information about what's below. So if I had just an abstract syntax tree of this particular class, and I ask you the question, is this an SLF for JLogger, or is this a log for JLogger? Couldn't actually answer that question without some more information available to you. And so the lossless semantic tree that Open Rewrite is building on, it starts with the syntax. It starts with this kind of green thing. There's like a compilation unit, there's a class, there's a block, there's a method, etc. This is all the syntax. But the blue nodes are really like the compiler going through and figuring out, oh, I see this logger.info. This is like info on a log for JLogger, which means its declaring type is this. And then that data structure itself is deeply recursive, because you might be talking about a method on a class, which in turn inherits from an interface, which in turn inherits from a super interface, which in turn has other methods. And is this method an overridden method of something else? And so for one particular info method call here, there could be hundreds of thousands of vertices hanging off of it, of type information that may or may not be used to make a decision on whether or not I want to change this. There's some kind of more information, what we call markers, that are available on the AST as well, or LST as well, but that's the sort of information that we're looking for. You can probably hear already a kind of a hint at the first problem for AI-based large-scale code transformation here, which is that a lot of these like simplistic systems, or things that we want to do, just kind of shovel the text of the code into an LLM and ask it to make a change. And to some extent that works. To some extent the LLM is missing information about what this is, and therefore how can we expect it to make the correct choice, ultimately. The easy excuse right now is to say the models keep getting better and better and better and better. They're smarter and smarter and smarter. They're better able to reason, but the smartest model in the world will be no better able to reason about this than I am, lacking any further information about it. The kind of second problem, I think, if we were to just kind of like ask an LLM to make the same kind of change that we saw over here, you're only ever going to see the positive, like the changes that were made, and not the changes that were not made, that needed to be made. And there's a certain class of change that you could do compilation verification, you could do test verification, you could do multiple steps of verification and still miss like a required change. We were at, I think, SAP about a year ago, working on an application that had been already manually migrated. That had already been manually migrated from Spring Boot 2 to 3, ran this recipe. This is kind of like every one of these. It's a composite recipe that has like many individual steps on it. So to migrate from Spring Boot to Spring Boot 3.3, you need to first get to 3.2, which means you need 3.0, which means you need 3.0, which means you have to migrate to Java 17, which means you have to get to 11, which means you have to get to 8, which means you have to get to 7, which means, so like each of these is an individual kind of like step in how to get there. And if I just look at the property only changes necessary, like all of these sort of like green nodes here are just the Spring team decided to change application properties to use a different property name, or so it's going to occur in property YAMLs. Your compilation's not going to pick that up, and your tests may or may not pick it up depending on whether it's exercised, in that profile and that sort of environment. And so in their case, there were a whole lot of these property changes that had happened over a number of releases that they were just missing. And so there were certain parts of their telemetry that were no longer getting through, and it was just like, oops, things get through. So it's the negative space in some cases, I think, that's harder to verify than looking at the changes that have been made and trying to understand, whether the change that was positively made is correct, if that makes sense. So I think it's, I'm trying to, maybe it would be helpful for a moment to think about like other kinds of, recipes that I ran and give some like further examples of where you need like information that's below the surface of what you can see in the text of the code. And so some of these are code sort of things, and some of these are dependency related things. There's an interesting case for like upgrade dependencies. Like upgrading dependencies is a very complicated problem, in the Java ecosystem in particular. If I pick on something like a Jackson is, of course, for no fault of its own, famous for, being targeted by the next CVE by some enterprising security researcher who thinks that, there's going to be like a obvious remote code execution vulnerability, and Tatu, the poor Jackson author, has to keep going back and adding like exclusions, like exceptions to his like a polymorphic deserialization to close these. And Tatu is a very diligent person, and he's very good at going back and back patching old minor releases with the fixes for these CVEs as they come out. But for anybody that's used Jackson for a while, there's a lot of different artifacts, and if your application winds up with a mixture of different minor releases of the same Jackson version, like 2.7 and 2.11 or 2 whatever, you're in for a world of pain, right? That app's just going to break somewhere at runtime. So this problem of like, gosh, what I've always really wanted to do is just give me to whatever the latest patch release of the minor I'm already on. And something like a Dependabot doesn't do this super well, right? It always just wants to get you like the latest thing. But that's going to break Spring's violation. It's going to violate its expectations, or it's going to like see the direct dependency on Jackson data bind and rev that. But somewhere you're going to transitively get another part of Jackson that's not going to be revved. Now you have the minor version conflict. You know, so this whole kind of thing. And so what I really wanted to express, and this is a recipe, an OpenArray recipe goes all the way back to the Netflix days, is to say every Jackson, subgroup, every artifact, I want you to get me to, and I wish there was some way of describing this in the build, just the latest patch release of whatever minor I'm already on. And so the recipes, you can say latest.patch, and maybe override managed versions as well. And actually this organization isn't that interesting. Let's move up a level. So if we run this particular recipe, how I actually override a dependency version is very specific to the build tool as well, right? In this particular case, this is a Gradle build. There was a fixed version. You'll notice I didn't move. This is a scary situation actually, where you've got direct dependencies on 2.4 and 2.7. This person apparently doesn't like themselves. The Netflix queue here. But rather than going immediately to 2.17, I just picked up the latest patch of the minor I was already on. Or, Spring Data REST is a Maven project, and I needed to get to 2.18.2 in this particular case. Or, so there's a lot of different ways in which this change gets executed depending on what I'm trying to do. And in the end, as a developer on a disparate set of repositories that use slightly different Gradle versions or Gradle Maven or something, ultimately what I want is just be able to commit all. Give me to the latest patch. I know Tatu has gone back and backpatched all the minor versions. Just give me to the latest patch. So, excuse me, the information about what version I was using was not visible in this XML, right? It was inferred from a parent version, or from a parent POM and some property or something like that. And so that's information that's below the surface of the text. If I asked an LLM, update me to the latest patch version of the minor I'm already on, excuse me, it wouldn't know, right? Which version I'm already on. Just a moment. I'm going to struggle. Another great example of this, I like to pick on my former team. Excuse me. This find usages of deprecated methods. Spring Team is famous for breaking changes here and there. I was part of the problem at one point. This particular recipe, find use of deprecated methods, just allows me to say, let's look for all the subtypes of the OrgSpring framework package, ignoring deprecated scopes for a moment. And if we run this on the 165 repositories inside the Spring organization, we'll see every method that was in use that at the time that was compiled was deprecated. So for example, this get module prefix here is deprecated. There's nothing about the syntax tree that really tells me that, right? It's something that the compiler knows by looking at the declaration, potentially looking at the supertype hierarchy and determining, is there a deprecated annotation anywhere on one of the declaring methods way up the hierarchy here. So excuse me. The so all these individual building blocks, thank you. All of these individual building blocks are potentially something that's really interesting to sort of, give to an LLM as tools for it to use when it's trying to make decisions, to kind of arm it with the information it needs to make the correct decision. So a big change I think that's come in the last year. I think we're already kind of like have moved beyond retrieval augmented generation, or RAG, to this idea of called tool function, or tool calling, function calling. And essentially what you do is your application, say you've got this chat interface, your application is calling the model with the prompt, but at the same time it's saying, I've got a set of tools, and if you have questions about something you don't know the answer to, that this tool does provide the information to. So when you call the model, you're calling it with a prompt, like some sort of question. At the same time, you're saying, here's a set of tools, here are the tool descriptions, and the model can either decide to respond directly, or can say, actually, I need to call one of your tools. And so when it calls that tool, it's going to provide like the parameters to call it in the form that you've described. You're responsible as the application owner to like call that tool and provide the response, the sort of data back to the LM, which it can then kind of fold into its understanding of the world. So this actually may happen multiple times. Like you do one sort of prompt, it calls a tool, it calls another tool, it calls another tool, it calls another tool. Eventually it builds up enough information that it will return a chat response to you. And so when it comes to the sort of like large scale impact analysis of like, I've got a large body of code, I've got 50 million lines of code here, I'm trying to understand where are all the deprecated usages. That recipe we just showed, like find deprecated usages of a particular package, is a tool that we can provide to the LLM to help it go locate all of those, and then allow it to use its reasoning to summarize and group and explain to you where the most common patterns really are. So I think this is a moment. This is essentially like the inversion of control moment for LLMs. You can think of this as having happened already with, think of this as like Spring versus J2E in some ways. Like we inverted the relationship between components and their collaborators. Here, like rather than like prompt stuffing all the data up front into an LLM when you're chatting with it, you're just providing the question and a set of tools, and you're allowing the LLM to make the decisions about when or if it needs additional data. And this tool function calling mechanism is really the foundation of, I guess, what we're now describing this year as, agentic experiences. The primary interface is chat, but there's potentially 1 to n tool calls behind the scenes that are going to supply additional data. This stuff is actually surprisingly simple from a end user's development perspective. I defined a tool that called that open rewrite recipe that would find the direct transitive dependencies. I call this dependency usages. I might say, this is a tool. I'm providing some textual description of what this tool is capable of providing. And then I'm going to say, I have a parameter here, which is I'm trying to get it to understand the Maven group pattern, Maven artifact pattern. And I'm saying when I ask about Guava, think about what the Maven dependency coordinate is. It usually has the structure, and formulate your question in this way. And so it may call this particular tool all I'm going to do behind the scenes is run this recipe and provide that data back, to it in some larger way. This is the LangChain for J library right here. There's similar frameworks that are trying to, like Spring AI is trying to do this. Has anybody used one of these yet in their sort of day-to-day? What's that?
Proof of concepts.
Proof of concepts, yeah. I think our exploration at this point has shown that this interface, like this tool interface, the model that's actually operating behind the scenes, OpenAI is capable of tool function calling, Anthropic is capable of it, Llama is capable of it, Gemini is capable of it. The model itself is pretty commodity. Doesn't really matter which one you use. They're all sort of similar in their output. The programming model is consistent, between all of them. So I've been struggling a bit to speak, so I'll just kind of go to questions at this point. Hopefully this has been interesting to this point. Happy to kind of dig into any of this stuff more.
The LLM integration is pretty interesting. The LLM integration is pretty interesting. How has it impacted the framework of Open Rewrite? And I see you're using tools here, but are you reconsidering the entire approach to evaluating the code base and things like that?
Yeah, I think ultimately any one change suggested by the LLM is probabilistic, as we've seen. So when this probabilistic scheme works really well for code assistance, which are net new code development in my IDE. I use Copilot every day. Copilot occupies this space, like this negative space that wasn't already occupied by IDE rule-based refactors. So where I needed to generate documentation strings or something like that, obviously an IDE rule-based refactor will never describe a method in documentation to me. It's just not what it's designed to do. But I mean, how many Copilot suggestions do I accept for the number that I see? It's still relatively low. I'll accept and I'll immediately modify. So I think it's very good for that sort of net new creative development, not suitable for large scale change that looks very similar from place to place. In essence, it's like what I want is a cookie cutter that spits out really highly accurate, low variability, lean six sort of cookies. What I could use the model to do is develop the new recipe. But once I have that recipe, I want to verify it, I want to test it, and then I want to sort of make hay that recipe to the maximal extent. And I think it's tempting. It's very, very tempting if for a lot of folks right now, if you're very new to the space, to give it a class and say, convert this from this to this, or from this version to this version, and see some good output and think, we're so close, this should work, right? And it's just missing that step of repeatability it's going to be pretty hard.
The issue with the LLMs have to run on the web scale.
It is very expensive.
It's very
Yeah.
expensive and very slow.
Yeah.
So that's where you need mostly to have as you said, to generate the recipe, which then apply it with the framework.
Yeah, yeah, much more efficient operationally on some level. Yeah, really, really good question, I think.
Yeah, the cost and latency of trying to do this with AI is
Unreal. Yeah.
And electricity wise, much more expensive than one.
Yeah. that latency actually gets magnified too when I think the temptation for these like large scale agentic systems for change like this would be you can kind of like draw out the boxes, like have AI make code change, then follow it up with run compiler, run unit tests, and then if one of those two things fails, do another edit, then run compiler, run unit tests. And that's sort of architecturally simple, it's conceptually simple, but if I've got 1,000 repositories and I just need to compile all of them right now, it's very computationally expensive, both in just time and actually resources. And even if we had infinite time and resources, how I invoke the build or compilation and tests on an arbitrary repository without seeing it, or without like manual configuration on a per repository basis, is actually a very difficult problem as well. So you're going to encounter one repository and it's like Maven 3, and this one's Gradle this, and this requires this Java version, and this requires this input, and this one uses that. So that's, I think, a bit, underappreciated in just how difficult that is.
So the Amazon code queue transformer is advertised in Java 8 to 17 migrations as realistically implemented by running OpenAI recipes, and they only support Maven and only single module Maven projects because they cannot really figure out how to compile them in the cloud.
Yeah.
Thank you.
So you mentioned like there's multiple, you support multiple build tools, but does it support multiple language like other than Java?
Yeah, there's really an interesting, thanks for asking that question about multiple languages. When we started out, so Netflix is almost entirely Java. I promoted Kotlin very early there. That wasn't very popular, but so there's kind of Java, Kotlin, a little bit of Scala. And so, not surprisingly, when we started, we also started in the JVM, big enough footprint after all. As we started looking at expanding languages, the first language we expanded into outside Java was COBOL.
Yeah.
Kind of, oh boy. So, but it's just a funny aside on that. We thought, oh, how hard can this be? It's pretty procedural, right? And so Java has, I'll give you the Java side. Java has roughly 40-ish distinct syntax elements. Like if you count them up, like for loop, if statement, method declaration, etc., something like 40. Can you guess how many are in COBOL?
4,000.
No.
Kind of close. It was close to 2,000. And so it was just like, oh my gosh. So anyway, it wound up being, it's one of those like typical engineer, yeah, I'll have it done next week, and then, oh god. It's 50 times harder than I expected. But anyway, when we went on to like a JavaScript and started looking at that, we were thinking, okay, well, different build tool, different language. We're just building up that LST model again from the beginning, and got a little bit into it and was like, this looks awfully similar to the J interface, the Java LST root. And I guess that's kind of expected in some ways. These are all C family languages, so they share a lot more history than they have than is unshared. So we found that like 90+% of the LST elements were no different at the LST level between Java and JavaScript. They were printed as text very differently. When you try to take that LST and print it back to source, like the way that keywords are organized in a method or something could be different. Obviously, there's the semicolon thing. There's a lot of little things like that. But the LST data itself was the same. So anyway, we kind of have gone forward now, and as we built out JavaScript and Python and C# and Ruby, those LST models extend from the J model. A very surprising outcome to us, which means that some of the recipes we wrote for J originally, like change method name, change type, a lot of these base building blocks just actually automatically work. on JavaScript or Python or C# as we brought those languages online.
Yeah, in my head, the use case I was thinking of was sometimes I change something, and it's like in Scala, and then suddenly, like microservices, we're talking on like Kafka, whatever. So there's another service down the stream, like even SQL, like just a table. That would be nice to like have refactoring even in SQL, not even something like.
Yep. We it's actually not an uncommon use case that like SQL migration, and this is one recipe we keep more closed now, but Oracle to Postgres migration, or I'm trying to move Sybase to MS SQL to do a cloud migration, or there's like a lot of these variations. Or I'm just trying to add a new column to an existing table or modify it in some way. I got to go try to find all the use cases.
Yeah, and we, like you were talking about hidden stuff, for example, we had a field in the struct on a table, and someone down the stream select the struct, not even star, just the struct, and suddenly it breaks for them because the table that they write the struct to does not have that new field that you added, and suddenly you break like everything. It's insane.
Yeah, very subtle. On what's interesting about these problems, so we have this like find SQL recipe now. This is one variation of it. I think there's more sophisticated forms of it, but let's see. I'm trying to think of somebody that has a lot of. I guess Spring should have enough SQL. So this was like find SQL function in use. And the problem with something like, even if we just limit this to SQL for a moment, is that it can exist all over the place. It can be like in a string literal, or it can be in a resource file, or it can be over here or there. So our initial goal was just go find every SQL query everywhere that it can occur in code naturally. And you can start to map ORMs on top of that and so forth. But if I cancel this for a moment, in a place where we were trying to do an Oracle to Postgres migration, the real question was like, where is the Oracle specific syntax? Because some of these queries I don't need to modify, some of them I do. And so OpenRare recipes, in addition to making changes, can emit rows of data we call data tables, according to a columnar structure that's defined by that recipe. And this particular recipe emitted a row for every, you've got these backwards, but for every, this is like function, this is query. But for every SQL function it found. And so the now function was used by this query, select now, or value was used, or concat was used, or so forth. And this is now an inventory of every SQL function that's in use on that 165 repositories. Now imagine running that on 500 million lines of code. Now I have an like inventory of every SQL function in use across all 500 million lines of code. And so to them it was like, let's do sort of this like pivot table on this, and then look for Oracle specific functions and where is the Oracle specific syntax predominant. And there were whole business units that the only Oracle specific functionality or like query was NVL, which can just be replaced with coalesce and you're off to the races. And so it's like the way they think about planning that exercise now is very different. And yeah, I'll make the recipe to replace NVL with coalesce. Some of these are going to be much more complicated, but you can kind of plan it out. Whereas before it was like such an overwhelming question, whereas the Oracle specific syntax, just nobody ever did it. Yeah.
So what does the step look like afterwards? So when you hit run and it goes to hundreds of repos, thousands, how do you test all of those? How do you, and you mentioned something also about resources are limited. So I guess is there some kind of constraints around, let's say they're all GitHub actions, how do you know you're not just killing all the runners, you know, stuff like that.
Yeah. That can be somewhat unique to each organization, like how they meter out how many PRs you can issue at any given time. But in general, I think for testing, we think of recipes as programs, and programs are it makes a predictable change. And so a program can have a bug, we discover a bug, we fix the bug, we just do it again. Much better than having done it all manually, deciding that what I did manually is wrong, and then having to go back and do it manually all over again. Really exciting technology recently that's somewhat new to us, and so we're discovering more of the scenes around this. But we figured out recently how to do compilation verification on a per file basis that changes are made without actually executing the build. So when a particular file is changed, we know all the things that it uses, and we can essentially give it to the compiler alone. And so that enables really rapid pre-giving it to CI verification of whether or not this project's going to compile or not. And for all those that don't, just don't issue the PR that causes CI infrastructure to be spent. That quick compilation verification technology, I think, is, again, an essential building block of any agentic system that ultimately does large-scale change, because right now it's just very, very, very expensive to do that. Over and over again.
Like thinking of a step more like these impact the business, right, or something. So doesn't that have a constraint on the resources there, like people testing and exploratory testing, whatever needs,
Absolutely.
changing fundamental
Absolutely.
stuff, foundational
Absolutely.
infrastructure stuff. So
I think that's always true, and in this case, yeah, absolutely. I think that's absolutely true still. That and actually when I think about the Dev Center again, we're looking at a priority set per organization. There's going to be organizations that have a higher degree of test automation and maturity, and organizations with lower, and we just don't expect the same throughput of that change through both of those organizations. But what's true for both of them is that, regardless of how mature their QA cycle is, they still would have to make the change. And so I think we're trying to stay in the lane of well, we can solve that part. I can't change all the cultural impacts of what their testing cycle looks like all at once.
Program that you were using earlier, GSD, right? GSD?
LST, yeah, the lossless
Okay.
semantic tree, yeah. This is the
Loss systematic tree.
Yeah,
Okay.
that's this view of the code that has both the syntax, everything the compiler knows about it, and some other metadata
Okay.
on top of that as well.
Is it similar to CSP? CSP, no, ASP is abstract, CSP is the code that where it's looking at all the information, so it's kind of the same, right?
Concrete does not have semantic data types. It just has syntax, full syntax and white space. ASP does not have that.
Yeah, white space is something that's often thrown away early on, and when we're using it to go not for code search or scanning, but rather to make change, all that original white space, we have to go stuff that back on the tree as well, and that's what makes us able to take the tree and print it back out to text without losing any of the information about it.
But if you can use, for example, cursors, the position, location for each tree. So where it starts, in that case, you don't have to store information. You can store it from. So if you store the location on the node, like most of the compilers are doing, so once in that case, you have to store all the spaces, because you can recreate them when you go when you print it.
Yeah, we'd avoid storing index positions in the code and then the original code, because then as the code changes, those index positions
you have to
get very complicated. So instead, each the white space that exists ahead of this logger statement is stored with this, And now I don't care. Like I don't on an individual tree like level. I don't care to store what line number it was at. That'll be determined as I print it
Well,
back
that's
out again.
justify, right? Have you justified or not? I believe. It's named justify or?
It's like we have like the right padded, the left
Oh,
padded.
right part, so-
Yeah, yeah. So we
right.
store padding information on the tree as well. Yeah. And yeah, that was all part of. Again, if this had started at Google, I would not have done any of that, right? Because I would have said, forget about it. I'll just run Google Java format at the end, right? Because we all require the same standard. But that was anti-cultural. Yeah.
The LST, you had to build that yourself, right? Java does not provide anything for that.
Interestingly, what's actually being mapped there, so, we could have started, there's a project out there called Java Parser, which is like, builds the tokenizer and abstract syntax tree and everything. I did not want to do that because I didn't want to re-implement all the type solving that the compiler does. So the compiler builds its own internal abstract syntax tree. It type attributes it. But it has thrown away formatting because the compiler only creates an AST for the ultimate goal of producing bytecode at the end. So it's discarded comments, it's discarded white space, there's some other stuff, and it's not designed for serialization either. So we essentially guide the compiler through the first couple phases of compilation and then look at its internal data structures and like rip all that out and put it over here in one that we know is instead suitable for change after the fact. And so we do that with Java, but then that's what we have to do with JavaScript. That's what we have to do with Python. That's what we have to do with C#, is exercise the internal guts of the compiler and kind of guide it through its first few phases, pull all the information out, and then.
This is interesting because I'm not too much of a Java developer. I'm more of a Scala developer, and we like it's something called SemanticDB, which does all of that, and it's the compiler that outputs it. And then we have like stuff like ScalaFix, which is inspired from GoFix.
Yeah.
Which actually uses, and we can rewrite rules in for each library, and it can like just do exactly like your example of the logger and everything. It would understand all of that.
Yep. Yeah, exactly. And Scala is the rare example of a language that kind of foresaw the need for that kind of tooling at the language level. Unfortunately, most of them don't. And so you wind up sort of trying to work your way back into that without it being natively provided by the compiler.
What I find funny also, the irony of it is that the biggest complaint in the Scala community is tooling is bad. And
is what, sir?
Everyone in the Scala community complains about the tooling not being good.
It's true.
But in the end, it's like stuff like that which are...
Yeah, in some ways it's ahead of its time. Yeah. That's always been the case with Scala, right? And in some ways it's like, IDE's like, yeah. Yeah. But
have you heard also about, so we have something called Scala Steward that does, it's like Dependabot, but it's able to apply the rewriting rules automatically when it upgrades the library. So it comes, it opens a PR, it upgrades the library.
Yeah.
But it also applies all the rewriting rules.
Yeah. This was a mode of operation that we promoted at Netflix, is that the recipe went with a new version of the library. It works sometimes and doesn't work sometimes because, in this case, like we had to have, for open rewrite, you have to have like it in an initially compilable state in order to then make the change. And so sometimes having it leads into a non-compiling state and all this kind of stuff. But in the end, like that model of like, we called it just-in-time refactoring or whatever, like the wasn't as desirable to end teams as being able to just pull and mass change as like a operation outside of CI or outside of individual change. I think they're both useful, but in terms of like where people derive the most value, it's
I wonder. So I actually work for Netflix.
Yeah.
But I wonder where this effort went into, because like right now, the most the most used thing is like a bot that comes and upgrades everything into a log file, and it doesn't even do a PR. I think it just like makes a commit with like ton of upgrades of all the dependencies, and I don't know. I hate it myself, but because it's like it just upgrades a ton of things, and then when it crashes, you're like, okay, one of them, but you have no idea which one. So
Yeah, I don't think they do this kind of thing as much anymore. I don't really know.
So
It was-
interestingly, there were a couple of presentations from Netflix from their news team,
Yeah.
where the person mentioned open rewrite really in one corner, but there's like Spring Boot migration. We've seen some contributions of issues from various people from Netflix in open rewrite, but they kind of wrapped it into so many layers of abstraction of various internal tooling that it's just you wouldn't see it.
And it's true. I
They
think
configured it themselves, so it's just.
at the time I left, one of my colleagues was very against this approach and really was instead interested in like revving versions and then like building transitive closure of downstreams and like determining where that broke, and I don't know, like, so I don't think we had the same philosophy of where to take things, but he's still there and I left a long time ago.
what year was it? Were you?
I left in 2016.
Like, when I checked the log history, I saw that your commit up to 2016. Then it was few commits in the open rewrite by some other guys, and then like you started to commit around.
Yeah, because I mean we had set this on the side for
in 2020, right? You
Yeah,
started the game.
yeah.
So for 4 years, like there was almost no.
Yeah, except for whatever was happening internally that would be not visible to everybody else. So cool. Well, thanks for the questions. I'm happy to stick around.
I'm trying to change, to give the ability to change from one language to another one, because you have the LSTs which have all the information, and so because there is like a ReSharper tool which what they did, like they get all the Java code for the Android and they convert to the C#, and they were able to build Xabotas, which was running, which was working actually.
Yeah, I feel like language to language stuff, like it's a bit where I draw the line. Like I think
that's what actually drives me. Like, and I try to see if I can use like open rewrite, like the LSTs, and try to convert to the different language and to see how it works.
Yeah, I always feel like there's too much like creative exercise in going language to language, you know. But I think there's value in like using the data tables to extract information about like what needs to be there or like what you need to design around. But personally, I've never been a belief in the like automated COBOL to Java, you know, and still kind of, if anything, maybe that's an AI use case, but I see that not as a large scale refactoring, but as like an authorship tool. Is like I'm taking COBOL and I'm trying to author net new Java code that looks like
it's like a business, because lots of the companies who have COBOL and who wants to move to Java.
Yeah, it's it's definitely not a focus area for us, but yeah, let others do that. Again, happy to answer a little bit more, and you know, thanks for coming. Appreciate it, and thanks for the. It helps. Yeah.
Let's do a wrap up. Thank you, Jonathan. He's great for coming. I really appreciate it, Jonathan. I really appreciate hosting.
You too.
And Olga, appreciate it as well. Thank you so much.